Okay, this video is to compare and contrast the difference in savings in the Keynesian and classical models. So you might remember that in Keynes, it's all about aggregate demand and aggregate supply. So in Keynes, when there's an increase in savings, that's the same thing as saying there's a decrease in consumption. And since consumption is a component of aggregate demand, a decrease in consumption would be a decrease in aggregate demand. And in the Keynesian model, the economy would shrink. Aggregate demand would be down. Production supervisors would see inventories piling up in their warehouses. They would lay off workers, and on it goes. So in the Keynesian model, savings is a bad thing. In the classical model, when you increase savings, it causes an increase in the capital stock. Because remember, in the classical model, market's clear. So saving and investment equilibrate in the capital market. So when people save more, it's just more money to be invested. So when saving goes up, investment goes up, and investment is needed, or capital stock is needed in production, so it causes production to go up. There'll be more output and more income. So these two models couldn't be more different in their treatment of savings. So I've taken a couple of slides here to help you understand how this is. Let's see if I can make it work. Here we are. So this is the impact of savings on the Keynesian model. So if you think about the Keynesian model, it's all about aggregate demand and aggregate supply, which is the same thing as income. If you drew a 45-degree line in this graph, then anywhere on this 45-degree line, the Keynesian model would be in equilibrium because aggregate demand would equal aggregate supply. So there's a kind of a graph that is very common in textbooks called the Keynesian cross. And this line represents aggregate demand because it's made up of personal consumption, business investment, government spending, and net exports. So this is aggregate demand, and here is the spot where aggregate demand equals aggregate supply. So right here is Keynesian equilibrium. This spot would be where, according to the Keynesian model, the economy would operate here. Anywhere to the left of there, aggregate demand is greater than aggregate supply and the economy would expand. Anywhere to the right of there, aggregate demand is less than aggregate supply and the economy would shrink. Okay, so here's what happens when we have savings. If we have savings, that equilibrium won't happen. Now watch this. If we save more, consumption will fall. And since consumption is a component of aggregate demand, it'll cause the aggregate demand function to fall, and we'll establish a new equilibrium at this lower spot, the new equilibrium. So in the Keynesian model, increase in savings causes a decrease in consumption. A decrease in consumption is a component of aggregate demand, so aggregate demand falls and equilibrium income falls. All right, now let's look in the classical model. So the classical model is different, and I need to give you a little bit of background. In the classical model, first we have production. So we need some function that describes production, and it's normally described this way in what's called a Cobb-Douglas production function. Don't be intimidated by this equation. This is just a mathematical algorithm that economists use to predict output. This is output right here. K stands for capital, even though we spell it with a C. In the equation, it's always written as a K. So this is how much capital is in the economy. This is how many workers are in the economy, and this would be output. So here's a simple, one with numbers in there if you wanted to put it in your calculator and figure out what this is. It just says that output is equal to 50 times the number of units of capital we have raised to the 0.4 power times the number of units of labor we have raised to the 0.6 power. Okay, so this is how we model production in the classical model. Pay close attention to there's this capital variable here. All right, so second, we have capital depreciation. Keynes never talks about this in his model, but it's obvious. If you have a bunch of machines, they don't last forever. They wear out at some rate, right? So we have capital depreciation. That is, capital wears out and must be replaced. So in this case, as the years go by, or as the periods go by, there'll be some depreciation here. Capital will get reduced, and output, if it's not replenished, if the capital stock's not replenished, output will fall. So capital depreciates and must be replaced in the classical model. All right, so third, in the classical model, remember that market's clear in the classical model, so saving equals investment. And this is how it's shown. There is a demand curve for loanable funds. This is made up of borrowers. When the interest rate is really high, they don't want to borrow very much. And when the interest rate is low, they want to borrow a lot. And then there is a supply curve of loanable funds. It's made up of savers. When the interest rate is really low, they don't care to save much because what's the point of it? When interest rates are high, they're motivated to save a lot. And there'll be some equilibrium interest rate that equilibrates savings and investment. So in the classical model, remember, market's clear, so saving equals investment. Good. Now, finally, since saving equals investment and investment leads to new capital stock, saving contributes to production. So in the classical model, saving is a positive thing. But don't get too excited, because even though there is saving in every period, production doesn't increase indefinitely. Can you see why? You can stop this video and think about it if you want. Even though there's savings every time, production won't go up forever. The reason is because as the capital stock increases, depreciation also increases, right? So if you have 10 units of capital and one depreciates every year, then you got to replace one every year. If you have 1,000 units of capital, then 100 of them are going to depreciate every year, and you got to replace 100 of them every year. So as the capital stock gets bigger and bigger and bigger, the burden of depreciation increases. And eventually, it's completely offset. So that is, eventually, net investment becomes zero. That is, the amount of investment that's coming from savings goes completely to replace machines that have depreciated. All right, so if you want a more detailed and precise explanation of what's going on, you need to look at this Excel file, which I've also prepared. Let me pull it up for you. So this is an Excel file for the Keynesian model. Now, what I've done in this model is I've set government spending to zero, net exports to zero, taxes to zero, autonomous spending to zero. I just did that to make it really simple. In this very simple Keynesian model, all we have is consumption and investment. So aggregate demand, this column right here, is just the sum of consumption and investment. Here's output over here, or in the language of Keynes, this would be income, right? Aggregate supply or income. So you see output is at 957.89, and that's exactly the same as the sum of consumption and investment. So this model is in equilibrium all the way down. And here's all the periods. You can look at them. Here's all the periods. Nothing is going on. Okay, now I've set this up in such a way that we can change savings right here in period 11. See this, the blue line here? I can change the savings. So let's increase savings from 15%, say, to 20. Another way of thinking of that is savings was 15%, so the marginal propensity to consume was 0.85. And now with savings at 20%, the marginal propensity to consume will be only 0.8. So Keynes says if we increase savings, the income should fall. So let's see, I'll hit enter, and you can see that what happens is when people save more, income falls, attains a new equilibrium down here, and consumption falls. You can see it right in here. If you notice, from period 10 to period 11, people saved more. You see this? And when they saved more, it made their consumption fall. You see that right there? So consumption, this lower number here, plus investment, which is the same as it was before, leads to less aggregate demand. So now aggregate demand is less than aggregate supply by this number, minus 47.89. So that means that production supervisors are going to lay off $47, or maybe this is hundreds of thousands of dollars, of workers. So in the next period, output is less. But of course, when output is less, there's less income, so consumption is less again. See how it's fallen? And then again, aggregate demand is less than aggregate supply, and it continues. It's closing the gap, but it continues until finally the economy falls back into equilibrium way down in here somewhere. So to summarize, when you increase savings in the Keynesian model, it causes aggregate demand to fall through the consumption function. Consumption fell, so aggregate demand fell. Look at it right here. And then, of course, there's all those adjustments through the multiplier as production supervisors make their adjustments. And the economy shrinks. So let me set this back where it was at 0.15. Okay, now let's go over and look at the classical model. Now, in the classical model, I'll set these numbers so that they would be the same, so that it would be easy to compare. But in the classical model, we have this production function where the constant is 5. The initial capital stock was 1,436.84. The initial number of units of labor was 50, and alpha and beta were 0.4 and 0.6. So you take these numbers, you stick them in to the output function, and you get this. Okay, this is output, which comes from this equation right here. People are saving 15% of their income, so 15% of this number is that. And then, of course, the balance is how much they spend, just like in the Keynesian model. These numbers are the same. Now, we need some assumption about depreciation, and I set the capital depreciation rate at 10%. So that means out of all the capital we had, which was this much right here, 10% of it depreciated. So 10% of this number is 143.68. So we had some capital depreciation, but we also had new capital coming in, right? Because savings equals investment. People save this much money, and so it was invested. So we have $143.68 of new investment, and we had $143.68 of capital depreciation. So the net change in capital is 0, and we're in equilibrium. So in the first 10 periods, we're in equilibrium. It's all good, right? Looks just like the Keynesian model. Now, I've set this spreadsheet up so that I can change the savings rate, and the change occurs in period 11. So let's save a little more, just like we did in the other one. Let's save 20% and look and see what happens. You'll notice that when we save more, consumption goes down at first, but then it grows to a higher level than before. You can see it right in here. So what happened is people save more, so their savings increased, and of course their income was the same. So when they saved more, they consumed less. That thing went down, consumption went down, but this new extra saving generated new capital, right? We had this much depreciation, but we had this much new investment. So we had a net increase of investment of $47.89. So that $47.89 is added to the capital stock, which made output grow. See how output grew here? And then, of course, it grows again and again and again and again. The capital stock keeps growing. Of course, as it grows, the burden of depreciation is also growing until finally they equilibrate way down in here somewhere, and the process just stops. Well, I didn't quite get enough iterations, but you can see that it's going to 0. So in the classical model, when you save, it's a positive thing. It leads to new investment, and income grows, and then, of course, consumption also grows. There's this little dip right here. I might ask you about this on the test. How come consumption falls at first in the classical model? And the answer is simply, well, if they saved more, there's less to spend, right? But because they saved more, there's more capital stock, and so the pie gets bigger and bigger and bigger. So even though they're spending a smaller fraction of the pie is growing until finally they're better off than they were. Now let's go the other way. Suppose people save less. So instead of saving rate being 0.15, let's let it be 0.10. So in this case, look and see what happens. If you save less, then you can't maintain your capital stock. Depreciation is outstripping investment. Capital stock falls and output falls. Consumption goes up initially because you're saving less. There's more money to consume, but the pie is shrinking. So in the end, it's a polar opposites. In the Keynesian model, saving is a bad thing. In the classical model, saving is a good thing. So I hope you found this lesson. I hope it clears this up for you, and good luck on your exam. Let me see if I can figure out how to turn this thing off.